Okay, so today we're going to talk about a concept called moles and molar mass. Now, this is going to be the start of Unit 6, and you should have this handout right out here, these guided notes. Now, the mole is the counting unit used by chemists to indicate the number of atoms, ions, or molecules or formula units in a particular chemical sample. All right, if we're talking about a single element, it would be referring to atoms or ions. If it's talking about a compound, a covalent compound, it would be molecules, and then formula units is for ionic compounds. All right, the mole is similar to other counting units that you've used before, like a pair. If we talk about a pair, that means 2. A dozen means 12. Gross means 144. But 1 mole of a compound contains Avogadro's number, and it is 6.022 times 10 to the 23rd molecules or formula units. Now, so what we're saying is 1 mole of any substance is equal to this 6.022 times 10 to the 23rd atoms. If we're talking about an element, molecules, we're talking about a molecular compound or covalent compound, or formula units if it's an ionic compound. The molar mass of a compound tells you the mass of 1 mole of a substance. So make sure you know that. So 1 mole of a substance is equal to its molar mass. So in other words, it tells you the number of grams per mole of a compound. The units for molar mass are grams per mole. Now, mole, sometimes we abbreviate as MOL. It's not much of an abbreviation, just knocking off the E, but you'll see me write it like that a lot of times. That means the same thing. So, 1 mole, 6.02 times 10 to the 23rd things, atoms or molecules. And we define the mole, a few different ways. We define it this way in terms of atoms or molecules, but a mole can also be equal to the atomic mass of an element. So atomic mass is the mass of 1 mole of any element expressed in grams. Now the actual units are something called AMU, because we know these elements are very, very small. So we're talking about their weight. It's in atomic mass units. We just use grams to simplify things, because that is, we can't see something so small like atoms, so we deal with it in grams just to make it easier. So one way of looking at it is whenever you go to say buy dog food, you don't go and ask for, I want 500 pieces of dog food. You don't do it. You buy it by the pound. All right, so that makes it easier. You can deal with it better that way, and that's the way it is with moles also. These it's a way of linking the microscopic world of molecules with the macroscopic world of grams. So 1 mole of hydrogen is equal to 1.0 grams. That is its atomic mass. Now that's the mass. If you look on the periodic table, if you looked at your square and you have hydrogen, you got its atomic number on top. On bottom, you have its atomic mass, like that 1.01. And we're saying that is grams, even though it's really atomic mass units. But that's the atomic mass. That number on bottom is what we're going to be dealing with. And that number, 1 mole of hydrogen, is equal to 1.0 grams. That's how we define it in terms of atomic mass. We also call that molar mass. Atomic mass and molar mass are interchangeable. A lot of times we use atomic if we're talking about a single element, molar if we're talking about a compound. But it's also equal to 6.02 times 10 to the 23rd atoms. 1 mole of carbon is equal to its atomic mass, which is 12.0 grams. But that's also contains 6.02 times 10 to the 23rd atoms. 1 mole of oxygen is equal to its atomic mass, which is 16.0 grams, and that in a mole of oxygen would have 6.02 times 10 to the 23rd atoms. So in terms of atoms, a mole of anything has 6.02 times 10 to the 23rd. But define it in terms of atomic mass or molar mass, it's different. See, hydrogen, carbon, oxygen all have different atomic masses. Now, there's really no point in this number here. You need to know it, but as far as using this, we will never be counting by molecules. Molecules are so small that it's impossible to just, to count them. We can't even see them. So that's why we use the concept of a mole. It makes things a lot easier. Now, if you look at a chemical equation like 2Na plus CO2 produces 2NaCl. What that means, those numbers are in molecules. It's 2 molecules of Na reacts with this 1 molecule of chlorine gas to produce 2 molecules of NaCl. But to make things easier, because if we were going to do this reaction and we were going to add these amounts to it, we couldn't reach down and pick up 2 molecules of Na and 1 molecule of chlorine. It's too small. So we, instead of referring them as molecules, we refer to them as moles. So that would be 2 moles of Na reacts with 1 mole of chlorine to produce 2 moles of sodium chloride or NaCl. And then from moles, we can convert to grams, and we could actually do this reaction in the right proportions, adding grams to it. Now, if you look at these samples here, and this first one, 65.4 grams of zinc, that is the atomic mass of zinc. That amount right there would be 1 mole of zinc. Carbon, its atomic mass is 12.0 grams, and that amount right there would be 1 mole of carbon. This is 24.3 grams of magnesium, which is magnesium's atomic mass. If you weigh that would be 1 mole of magnesium. So if you see, each one of these samples here, have different amounts to them, but they all equal 1 mole of that substance, because 1 mole is equal to the atomic mass or the molar mass of the element or compound. But every one of these examples would all have the same number of atoms, 6.02 times 10 to the 23rd atoms. So that would be constant for all of them, but they're but defined in terms of molar mass, it would be different for each sample. And we would have to look up what 1 mole of it is, so we have to look at its atomic mass to figure that out. Now, gram molecular mass is the mass in grams of a mole of a molecular compound. So you'll hear this called molecular mass a lot of times. You find the molecular mass of something, find the formula mass, that's the mass in grams of 1 mole of an ionic compound. It's the same thing. Or molar mass, that's just a general term for gram formula mass and gram molecular mass. So most of the time you're going to hear me call it molar mass. If you're asking a problem to calculate molecular mass, it's the same thing. Alright, so to find the molar mass of a compound, you're going to use the chemical formula to determine the number of each type of atoms present in the compound. So you have to be given a chemical formula. Then you're going to multiply the atomic weight from the periodic table of each element by the number of atoms of that element present in the compound. And then you're going to add it all together and put units of grams per mole after the numbers. So the units for molar mass are grams per mole. Now, can I give you an example? If we have H2O, on a molecular level, that would be, an oxygen atom, and it would be bonded to 2 hydrogens. Now, if we're going to find the molar mass of that, if we looked up the individual masses, if you looked it up for oxygen, it would be 16.00. For hydrogen, it's like 1.01. But I have two hydrogens. Both of them would have a mass of 1.01 atomic mass units, but we're going to say grams to make things simple. I would just add these up to find my molar mass. So the molar mass of H2O would be 18.02 grams per mole. So there's a few examples that will work for you, and then we'll work a few. So you can find the molar mass of sodium carbonate. It's Na2CO3. If you notice, I write down the symbols. And then I got two sodiums times 23.0. That is the atomic mass or molar mass of sodium. And then carbon, 1 times its atomic mass, 12.0 equals 12.0. Oxygen, 3 times 16.0, its atomic mass equals 48.0. I add all those up and I get the molar mass 106.0 grams per mole. Now, one thing about it though, this is to 1 decimal place. When we work these, we're going to go to 2 decimal places. On your periodic table, each one of your atomic masses is 2 decimal places, so we're going to leave it like that, and we're going to show our final answer to 2 decimal places. If you're checking answers on some of the homework problems or worksheet problems, they might be rounded to 1 decimal place. As long as you got something really, really close to that, where you're within a few tenths of my answer, you're fine on that. It all depends on how you round. But I would say, don't round on anything. Go to 2 decimal places. Now, next, what's the molar mass of calcium nitrate? Remember, if we have a formula that's in parentheses, that number on the outside of the parentheses that multiplies by the numbers on the inside of the parentheses. So in calcium nitrate, Ca, I have one of those times its atomic mass, 40.1. Nitrogen, I have 1 on the inside, 2 on the outside. It's 2 nitrogens times 14.0, its atomic mass, that equals 28.0. Oxygen, you have 6 of those, so that's 3 times 2 times 16.0, its atomic mass equals 96.0. And you add all those up, you get 164.1 grams per mole. So 1 mole of calcium nitrate weighs 164.1 grams per mole. So 1 mole would be equal to 164.1 grams. And also that number would be equal, though, in terms of molecules, would be 6.02 times 10 to the 23rd molecules. Notice that you must be very careful when you're counting the number of atoms present in this compound. Subscript 2 after the parentheses indicates that there are 2 nitrate ions. In order to figure out how many nitrates are present, you must multiply the subscripts. In this case, 1 times 2 equals 2. In order to figure out how many oxygen atoms are present, you must multiply the subscripts 3 times 2. Notice that the subscript outside the parentheses affects only the atoms on the inside. So that's just a reminder for you about counting the number of atoms. So let's look at some practice problems. Alright, so let's look at Fe2O3. Now the way I'm going to do this, my first step is I'm going to write the elements. This is made up of iron and oxygen. Iron, I have 2 of those. Oxygen, I have 3. So iron, I'm going to multiply those 2 atoms by its atomic mass, and I'll have to So if I look up iron's atomic mass, it is 55.85. And then oxygen, I got 3 of those times this atomic mass, which if you look it up is 16.00. So then I'm going to bring up my calculator. And I do 2 times 55.85 equals 117.7. Oxygen 3 times 16.00 is going to be 48.00. Now I just add those up. And I get 159.7. If I want to show it to 2 decimal places, it'd be 0.70. I can't forget my units. That's grams per mole. Okay, our next example is AgNO3, that is silver nitrate. It's made up of silver, nitrogen, and oxygen. I have 1 silver atom, I have 1 nitrogen, I have 3 oxygens. So I need silver's molar mass, and I look it up and it's 107.87. Nitrogen is 1 times 14.0, and I believe it's, double check it, nitrogen 14.01. Oxygen is 3 times 16.00. So that's going to give me 107.87. 1 times 14.01 is 14.01. And 3 times 16 is 48.00. I'm going to add all those up. And my answer will be 169.88, and that'd be grams per mole. So 1 mole of AgNO3 would weigh 169.88 grams. Next, looking at this compound, PB, Cr2O7, 2 on the outside. That's made up of lead. So I got PB, I got chromium in it, and I got oxygen in that compound. There's 1 lead, chromium, there's 2 on the inside, times that 2 on the outside for a total of 4. Oxygen, 7 on the inside, times 2, give me a total of 14. I'm going to multiply by their atomic masses. So I need leads first. I find PB is 207.2. Now look up chromiums. Chromium is 51.99, which I can round that to 52.00. Then oxygen is 16.00. So 1 times 207.2 would be 207.2. 4 times 52 gives me 208.00. So there's now go to 2 decimal places. So that top one would be 207.20. Then 14 times 16 equals 224.00. Last step, I was going to add all those up. And I get 639.2. That would be grams per mole. Okay, our last example, we have calcium perchlorate, would be the name of that. It's made up of calcium, chlorine, and oxygen. Calcium, I have one of those. Chlorine, I have one on the inside, 1 times 2 for a total of 2. Oxygen, I got 4 on the inside, 4 times 2 gives me 8. And then I need their atomic masses. So I'm going to look at calciums first. Calcium is 40.08. Now look up chlorines. Chlorine is 35.45. And oxygen is 16.00. Okay, first calcium at one of those times 40.08 gives me 40.08. And then I do 2 times 35.45 gives me 70.9. 70.90. And then 16 times 8 is 128.00. So I'm going 2 decimal places. And like in the example up above, I should have said 639.20. Then I add all these up. 40.08 plus 70.9 plus 128 gives me, if I did my math right, 238.98 grams per mole. So 1 mole of calcium perchlorate weighs 238.98 grams. That's also equal to 6.02 times 10 to the 23rd molecules. And actually, for this, it would be correct to say calcium perchlorate is a ionic compound, so it would really be formula units. But those, atoms, molecules, formula units, all kind of the same thing. Now, the problems right here, you'll work these out and then check your answers with the key that I provide.